The resistance of a component is a measure of how much it opposes current flowing through it. Let's consider a simple lamp that has an electric current flowing through it. Remember, this current will consist of delocalized electrons moving through the lamp. But the components of the lamp will cause the electrons to slow down, usually by making them collide with positive ions. This means the lamp opposes the flow of current, which means it has resistance. Resistance is measured in ohms, which we represent with the Greek letter omega. The greater the resistance, the more charge carriers will be slowed down by a component, and the more it opposes a current. Pretty much all components have some sort of resistance, but some are designed with resistance in mind. Resistors are components designed to deliberately reduce currents. We'll be looking at many different types of resistor throughout the course. The most common of these are fixed resistors, which have a set resistance value, though this value can change if the resistor heats up too much. These fixed resistors usually have coloured stripes that show what resistance value it has, though you won't need to know how to interpret this for your exams. Then the circuit symbol for a fixed resistor is simply a rectangle. The symbols for other types of resistors are then based on this. But what are resistors actually used for? Well, resistors are used to reduce the current in a circuit. Let's consider this circuit to power a lamp and a cell. If we had just these two components, there would be very little resistance in the circuit, and so we'd have a very high current in the lamp. This would be dangerous, as this can cause the lamp to overheat or break. So we've connected a resistor to reduce the current to a level where it is now safe to use the lamp. This is the main way we use resistors, though they can also be used to change how a current is divided in a branching circuit, or adjust a current as other conditions change. Let's now look at another key type of resistor. A variable resistor is a resistor that can have its resistance changed. This is what a variable resistor might look like. Inside is some high resistance conductor, and by turning the dial, we can change the resistance of the variable resistor by changing how much of the conductor a current has to travel through. Though instead of a dial, we could also have a slider or some other way of adjusting the resistance. Then the circuit symbol for this looks like that of a regular resistor, but now with a diagonal arrow drawn through it. So what kinds of circuits would this type of resistor be useful in? Well, a variable resistor can be used to adjust the resistance and current in a circuit as the current flows. For example, let's consider this circuit with a cell, a lamp, and a variable resistor. As we turn the dial on the variable resistor, it will cause the resistance of the circuit to change. Then, since all the components are in series, the current through the components will also change when the resistance changes. As a result, the brightness of the lamp changes as the current changes. So this is the type of circuit we'd find in a dimmer switch. By using a variable resistor, we don't need to disconnect the cell and change out resistors in order to change the current, making this circuit much more practical to use.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy to follow videos and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!